So in triangle ABC, BC is A, AC is B, and ABC, and ABC is 60. Use cosine rule, okay? So we've got B squared. Okay, whatever. B squared is A squared plus C squared minus 2AC cosine 60. Now, cosine 60 60 fingers here, cosine's on the left, so it's 1/2. So, we're solving for C. So, we're going to have I still have the cough drop. So the 2's cancel, minus AC, right? So basically it's quadratic. We want to get it equal to 0. C squared is the thing we're solving for. Plus A squared minus B squared. Oops. So in the quadratic formula, because we're solving for C, it's kind of confusing, but if we have our ax squared plus bx plus c, a is the thing that, so it's going to be ac squared plus bc plus, c, which is super confusing, but not c. Yeah, whatever, very confusing. This c, not this c. Okay, so anyways, we have 1, we have negative a, and then the constant is this. So we're going to have c equals negative b, which is negative a, plus or minus the square root of b squared, so negative a squared, minus 4, a is 1, and c is a squared minus b squared. And that's all over 2a. So we've got a plus or minus, and this should not be c squared, sorry, that should just be c. We're always solving for x, not c, x squared. So a plus or minus a squared minus, when we distribute the minus 4, minus 4a squared plus 4b squared over 2. So then we're going to have negative 3a squared plus 4b squared over 2. And if you look back at the thing, we want to get the 4, divide by 4. So here we have 1 over 2a plus or minus. When we bring this 2, because I've already done it over the a, if we want to bring it under the square root, it becomes 4. Okay, so negative 3a squared plus, I don't know what I'm doing. There should be a 4 here. Confusing. Okay, so now, we bring the 2 under the square root, that becomes 4. So 1/2 a, and then we have minus 3/4 a squared plus b squared when the 4's cancel. Okay, and then rewrite it backwards, but whatever. 42. Okay, so the following 3-dimensional diagram shows 4 points, A, B, C, D. A, B, and C are on the same horizontal plane, so they're on the ground basically, and AD is vertical. The angle ABC on the ground is 45, and BC is 50 meters. The angle of elevation from B to D is 30, so this is 30, while the angle of elevation from C to D is 20. Okay. I think we can assume that these are right angles. Using the cosine rule in triangle ABC, find AD. Okay, so we have some things we can figure out. We can find this angle, it doesn't matter. We can find this angle, also doesn't matter. what we really need to do, this can be W and this can be Y. And it tells us to use cosine rule. So if we use cosine rule, I'm going to use 45 as C. So this is little c. So we're going to have W squared equals 50 squared plus Y squared minus 2 times 50 times Y cosine 45. Okay? Cosine 45 is root 2 over 2. And those will cancel. Not that that really matters, but just simplifying it a bit. So now we've got these two triangles. So we're going to have tangent 30 equals opposite x over adjacent y. Tangent 30 fingers here. It's the y's over the x's. Okay. So this is going to be, the 2's will cancel, so 1 over root 3 is x over y. And we're going to solve for y here. So y, if you cross multiply, you've got y equals root 3x. Okay? So I'm actually going to put that in here. 50 squared plus root 3x squared minus 50 root 2 y is root 3x. Okay. The other triangle, this one over here, we're going to have tangent 20, which is not a special angle, equals x over w. So w is x over tangent 20, and that's going to go here. And that's squared, okay? And then this can go straight into end solve. And you should get that x, that height there, is 13.6 meters. This is very similar to the last one. It looks like we've got this three-dimensional thing. P and Q are respectively west and southwest. West and southwest. Okay. So I think that means that this is 45 degrees because south is here, and if that's southwest, it's right there in the middle. So I think that's 45. Okay. The angles of elevation are there, and we want the height here. Okay, so we're going to do the same thing. So if we have, first of all, tangent 35 equals x over w, and we have tangent 40 equals x over y in those two vertical triangles. And then on the bottom, we're going to have 20 squared equals w squared plus y squared minus 2wy cosine 45. And again, cosine 45 is root 2 over 2. And then those 2's will cancel. And we need to just solve this for w. So w is x over tangent 35. So that goes here. And this is 400. And y is going to be x over tan 40. So x over tan 40 squared minus w again, x over tan 35, y again, x over tan 40, and root 2. And then we should end solve this. And you should get x is 19.5 meters. Okay. Find the length. Okay, so hold on. We've got 7, 5, 60, 80, D, B, C, 30. So this is 50. No. 70. length of BD. So we have to find this thing here. I'll call that y. So cosine rule, y squared equals 7 squared plus 5 squared minus 275 cosine 60. 60 fingers here, this one half. So we're going to have 49, 25 minus 70 times 1/2, which is 35. So negative 10, so y squared is 39, so y is root 39. So for b, oh wait, we're not done here. So now we can just sine rule. So we've got root 39 over sine 80 equals x over sine 70, and we have to use calculator for that. So we get x is 5.96. So that's A. For B here, find the area of the quadrilateral. So we have 7 plus 5 plus the 5.96 plus, this is W. That's what we're looking for. So W, we're going to have W over sine 30 equals y. I'm going to use y because that's not rounded, over sine 80. So sine 30 is 1/2. So W is root 39 over 2 sine 80. We still have to use calculator. But then we will add that all together. So when I put W in there, you end up getting 21.1 meters or whatever. Okay. Oh, okay. Actually, this is C. That's the perimeter, adding all up. So for B, the area of that triangle. So we have 1/2 A, B, sine 60. That's this bottom triangle. Plus 1/2 root 39 times W, which is root 39 over 2 sine 80. And then sine of the angle between, so that's in between y and w, so 70. So that's going to be the area of the whole quadrilateral. So this together gives 24.5 units squared. And for D here, we have, it's given the bearing from B to D is 70. So if this is north, we have this is 70. Find the bearing of B from A. Okay, hold on one sec. So B from A. So we want that whole thing. Oh, that's fine. Okay. So first of all, this bit, if I fill this in, that's going to be 300. So we need to find this little bit here. Oops. This little bit here. So if we do some stuff, this is 110. And this here is going to be 170 because of a circle, which makes this little bit there 10 degrees. Because all these are supplementary. So we can find this bit here, 7 over sine x, whatever, equals y. What was y? Root 39 over sine 60. So that little angle is 76.1. This one. And then we can do 180 minus that thing. Minus 60. Oh, I don't think we actually need this. Whatever. This is 43.9. So we can find, actually, yeah, I think we're there. Because this whole bit and this whole bit will add to 180. So if we do 180 minus 10 and 70 minus that 76.1, so that ends up being 23.9 just here. So that whole bearing from from A to B is going to be 323.9 degrees. And now that I've read that stupid thing, I found this is double I. That's from A to B. Now, from B to A is actually, in yellow, this thing, which we have all of that. It's going to be 143.9. At least that took less amount of time. All right, 45 following diagram shows a pentagon. We got all that stuff. Find A to D here. Okay. All right, so we have cosine rule in this ADB triangle. So x squared equals 7.1 squared plus 9.2 squared minus 2, 7.1, 9.2 cosine 60. Okay. For B, we need D to E. So that actually requires sine rule. And if this is 162, this is 18 to get to 80. So we're going to have our x in the previous one over sine 110 equals what we're trying to find out, y over sine 18. So for x, you should get 8.35. And then for y, you should get 2.75. Okay, so the area of the triangle BCD, so this one over here, is 5.68. And then DBC, okay, so that's straightforward. 1/2 AB sine of that angle. Okay, so you get that B, that's 30 degrees. When you do this in the calculator, A to C, all right, that whole thing. So this is cosine rule again because we've got 30 here. Oh, no, because it's 90. So basically you're going to have, it doesn't look like it at all. So you get 90, this is 9.2, this is 3.2. And you want AC, so this is Pythagoras. 9.2 squared plus 3.2 squared equals x squared. So you get A to C is 9.74. The area of the quadrilateral ABCD. So we've already, they're just going back and forth, aren't they? This was D, this is E. So we've already got this area, so ignore that line, the red line. So we've already got the area of that triangle, which is 5.68. And to that, we're going to add 1/2, 7.1, 9.2 sine 60, because that's this one. Okay? So that's going to equal 33.96 or 34.0 units squared. And I was just looking through the mark scheme because we use sine here. They did do the alternative angle to be 150. But yeah, if that's the case, then that changes this angle in D. We would have this be 210, this 9.2, and this 3.2. And we'd use cosine rule to find that. Squared plus 3.2 squared minus 2 those things. And then cosine 210. Which ends up being 12.1. So that's A to C, the alternative A to C. And then that doesn't change anything in the bottom one.